Okay, in this video we're going to look at least the first two parts of an old free response question. So it says a function is defined by that power series, and you can see the general term and you can also see some terms listed out. It says find f prime of 0 and f double prime of 0. Okay, well f prime of 0 over 1 factorial, remember that has to be the coefficient. Just write coefficient for x to the first, right? They all agree. First derivative, 1 factorial, x to the first. And we go up here and you'll see that there is no x to the first term. It skips right to x squared. So that must mean that f prime over 1 factorial is equal to 0. Because if that term didn't appear, then the coefficient must have been 0. So that means f prime is 0. Now, that means that there's a critical point at 0 because the derivative is 0. Remember, a critical point is if the derivative is 0 or undefined, and the derivative is 0. So the second part of this says find f double prime. So f double prime over 2 factorial has to be equal to, in our case, you'll see we've got a, if I wrote this out, we'd have negative x squared over 6, which is the same as negative 1/6 x squared. So this coefficient, it's like this, okay, because the second derivative at 0 over 2 factorial gives us the coefficient for x squared, and the coefficient for x squared was negative 1/6. So I multiply both sides by 2. That means that the second derivative's value was negative 1/3. Now you see it says determine whether a local max, local min, or neither. Give a reason. Well, we know there's a critical point, right? We said that already. And the second derivative is negative, meaning the function is concave down, right? Negative second derivative means concave down. So there is a local maximum at that spot. Because, and it's a two-part answer. There's a critical point, and the second derivative being negative means that the function was concave down. Part B says show that 1 minus 1 over 3 factorial approximates f of 1 with an error less than 1/100th. Well, this is, of course, the first two terms in our series, plugging 1 in, 2 terms. Okay, so it's these two with 1 plugged in. Well, this is an alternating series, so error is always the next term. So the next term is this. Well, we plug 1 into that, we get 1 to the 4th over 5 factorial. That's 1 over 120, which is less than 1/100th. So there it is. It says show that the error will be less than 1/100th. We did, because the next term is less than 1/100th, because we're already within 1/120th. So those are the first two parts of this free response from a couple of years ago. Just, go through and use the using the formula to get the first, second derivative, and then analyzing what that meant about the function. And remember, an alternating series, all we need to do is go to the next term. Lagrange, if it weren't alternating, we'd have to do Lagrange error bound. That's a little more work. It still relies on the next term, but when it's alternating, we don't have to do that. We just go straight to the next term.